All right, Jennifer, thank you. Welcome back over here to Studio B. It's Wise Guy Part 2 time. Matt Selen is back, our U of I physics professor. Last time you made sound out of PVC pipe and then tinfoil, and you burned the transistors up.
Yeah, it sort of almost caught on fire right at the end. That was pretty cool.
That was cool. So now the relationship between a hammer and a rod.
Right. So the sound thing burned up. We can't do that again. But what we're going to do actually is we're going to make a magnet out of this piece of steel just by smacking it with a hammer.
Okay.
And the idea there is kind of two ideas together. One is that the Earth itself has a magnetic field, and of course that's if you're orienteering and you have a compass, you'll see the needle points north all the time. That's because the Earth has a magnetic north pole and a magnetic south pole, which sort of happens to coincide more or less with the north and south pole. Okay, and each piece of steel also has, you can think of them as being built up of little tiny microscopic bar magnets inside this thing. They're called domains, and these domains usually are oriented in such a way that the magnetic north in each little domain is kind of random, but magnets tend to want to line up with each other. So the Earth's outside magnetic field would like to line some of these domains up if it only could, but the domains are stuck. The way you can kind of unstick them is you can whack them with a hammer.
You can unstick a lot of stuff after whacking it with a hammer.
Now, it occurs to me that what's very interesting, and maybe in a couple of weeks we'll talk more about this, the Earth's magnetic field is mostly vertical where we are. It points a little bit north, but mostly it points kind of down. Okay? So I'm just going to hold this thing like this. I'm going to whack this thing with a hammer. Okay, when I'm doing this is sort of becoming the south part of the magnet. This is becoming the north part down here. And so if I hold this thing up to the actual magnet that you see there, you'll see that the magnet, the side of the red part of the magnet is attracted to the rod. That's because the south, that's the north pole of a little bar magnet, which is what the compass is, and it's attracted to the south pole of this piece of steel that I just smacked. Okay. Now, if I want to make this, instead of this thing that I smacked when I held it vertically like this, I made this a south pole. If I hold it like this and I smack it a few times, I'm going to be making that a north pole instead because it's pointing down. Now, when I hold the very same thing up to the magnet, you'll see that it attracts the other side. So just by smacking this thing, those little domains in there can jiggle a little bit, and they can reorient themselves in such a way that this thing becomes magnetized. That's why railroad tracks are magnetized, because they're steel, and the train runs over them all day long, and so they jiggle a lot, and so the atoms in those line up as well.
Okay, well, I'm thinking in my head the wheels are spinning, so if I'm playing horseshoes, can I magnetize the shoes to get closer to the peg here?
That's a fantastic idea, but it probably might not work because the magnetic force that you would need to kind of suck it in from many feet away, because if you're not shooting very accurately, you're going to miss it by many feet.
What if I'm just this close, but I need to be a little closer?
Well, you never know. It couldn't hurt.
Good.
Okay, but it probably wouldn't help either.
That'd be a fun experiment.
Yeah, so actually in a couple of weeks we come back and we'll do a little more about the Earth's magnetic field, because it turns out that the north geographical pole is actually the south magnetic pole of the Earth, which is sort of interesting. And we can talk more about this whole idea why the Earth's magnetic field is kind of more vertical than it is horizontal, which is a little counterintuitive.
That's interesting.
You sort of think as you're going like this, north is pointing, that way.
Right.
But really north is mostly pointing down into the Earth, and a little bit it points this way, and that little bit is enough to orient the compass needle so you don't get lost. Okay, but there's also other things like rocks and pieces of steel and buildings and lakes and things that can sort of alter the magnetic field by small amounts that can confuse you. And so we'll talk about that in a couple of weeks.
I think I'm lost right now.
Me too.
That's all. Thanks for coming in. Pretty cool experiments, and I don't think MacGyver has nothing on you, man.
Oh, yeah, he's a hacker.
Well, it's written out for him script-wise, right?
That's right.
We don't have any scripts. We're just talking.
That's pretty much it.
You got it. All right, if you want to see a replay of this segment, go to our website, IllinoisHomepage.net. Look under the morning show and look under Wise Guy. We'll get